Welcome back, everyone. Hope you enjoyed the quick break. My name is Daniel Pando, and I'll be hosting the next session here at the Almadina Room. I'd like to start by thanking everyone that is following Generation today, either on YouTube or on Slack. Our speakers, and obviously our sponsors for making Generation possible. I'd like to leave out a special thanks to our next speaker, Bouke Nijhuis, from Sync ICT. He's going to present us a session on how to build an app for the Google Assistant. Sorry if I mispronounced your name, Bouke.
Totally fine.
If you have any questions for him during the session, drop them on the Generation Slack on the Almadina channel or on the YouTube chat, and I'll try to relay them to Bouke. So without further ado, and when you're ready, Bouke, the stage is yours.
Thank you, Daniel. Welcome, everybody. Today, we're going to talk about how to build apps for the Google Assistant. So I would like to start with a little introduction, why I'm here telling you about creating apps for the Google Assistant. So my first contact with the Google Assistant was about 4 years ago, and I was pretty impressed. Actually, I'm still impressed. I think it's a great technology. And I wanted to know more about it. How does it work? And whenever I really want to know how stuff works, I have to play with it or I have to build something for it. So I decided to create my own app for the Google Assistant. And this became a little game called the Voice Adventure. And a voice adventure is like a text adventure, but instead of text, you use your voice. For people that do not know what a text adventure is, it's a game in which you interact with your environment by using text commands. Also, the game will respond with text. And it looks like this. This is a screenshot of Zork. This was a really popular game in the 80s. And like you can see, it's text all the way. Everything is presented with text. So I created something similar, but instead of text, you use your voice. So the goal for today is pretty simple. I want to show you how easy it is to get started building your own apps for the Google Assistant. At the end of this presentation, everybody should be able to build his own app. And I also hope that everybody is eager to build his or her own app. So hello again. My name is Bouke Nijhuis. I work for a company called Sync ICT. And at this point, I normally tell people, whenever you have a question during the presentation, please raise your hand. That's not going to work with an online conference. So please ask your questions in the chat, the YouTube chat or the Slack channel. And then Daniel will transfer the questions to me. If you're not live but looking at this later from YouTube, you can ask me questions at Twitter. My Twitter handle is in every slide in the bottom right corner. So the format for today is pretty simple. We're going to start with a demo in a minute. I will show you the game. Then I'm going to explain you how the game works. What are its most important components? How do they interact? What are their responsibilities? And then there will be a live coding part in which we're going to add a feature to the game. Finally, I'm going to wrap up the session. So I'm going to give you a demo of the game. I think that's important because it will give you a better understanding of the capabilities of the game, but also the capabilities of an app for the Google Assistant in general. Also, whenever I need an example, I want to show you something, I will take something from the game. So it's important that you understand the game properly. The demo will take about 2.5 minutes. I created a little movie up front. What you're currently seeing on the screen is the simulation environment. Whenever you create an app, you can test it here. There will be text involved, but that's because it's a simulation environment. You can play the game voice only. The text in here is helpful because then you can also read along. So here we go. Enjoy.
Here's the test version of Voice Adventure. Hi, welcome to Voice Adventure. You play this game like a text adventure, but instead of text, you use your voice. You can directly start with issuing commands or ask for more help.
Help me, please.
You can use verbs to interact with your environment. Use look to get a description of your environment. Use the verb go and a wind direction like north or east to navigate.
I see. Go east.
You are standing in a clearing in the woods. There is a bush on your right-hand side.
Okay. Look at the bush.
Under the bush lies an old iron handle.
Cool. Pick up the handle.
Added the handle to the inventory.
Nice. Go west.
You are at a crossing. In the north you see a castle. In the east is a clearing in the woods. In the south is a cave. In the west is a well.
Let's try the cave. Go south.
You entered the cave and there is a big troll coming your way.
Uh-oh. Go north.
You are at a crossing. In the north you see a castle. In the east is a clearing in the woods. In the south is a cave. In the west is a well.
Let's try west. Go west.
You are standing next to a dry well. The handle of the well is missing.
Handle. What's in my inventory?
You carry a handle.
Aha. Please use the handle on the well.
The handle seems to be part of the well. You use the handle to lift the bucket and you pick up the sword.
So that's the demo. I hope you have a better understanding of the game now and also of the capabilities of apps for the Google Assistant in general. Let's go back to the presentation. So the main components of this game are pretty simple. Actually, it's just a front end and a back end. So it's just like a business application. You have your front end, you have your back end. In this case, the front end is responsible for all the speech stuff. So it has to do speech to text, it has to do text to speech. And the back end is mainly responsible for coming up with a proper answer to your request. So if we put all this in a schema, it looks like this. First, there's me playing the game. I'll speak to the game. So the first arrow is voice. And then there's the front end. And then the front end will translate my voice into text. And then this text goes to the back end. And then the back end will apply some game logic and come up with a proper response. So again, text is going to the front end. Then the front end will translate this into speech. And I have a voice adventure. So this is how it works. Pretty simple in a nutshell. So now I'm going to talk a few minutes about the front end. And then I'm going to talk a few minutes about the back end. So the front end of the game is written in Dialogflow. Dialogflow is the most widely used tool for building apps for the Google Assistant. About 95% of all the apps for Google Assistant are written in Dialogflow. So whenever you want to write an app for Google Assistant, just use Dialogflow. Dialogflow is responsible for the speech recognition and the speech synthesis. It will do all the heavy lifting for you. So you don't have to know anything about those topics. Dialogflow will take care of it for you. What you do have to do in Dialogflow is model your conversations. And to do that, you can use 3 important concepts. And I'm going to dive a little bit deeper into those concepts. The first concept is an intent. In Dialogflow, you can model intents. So an intent tries to capture the intent of the user. So in the game, you saw several intents. You saw pickup handle. You saw use handle on well. Those are all intents. The player intends to do something. Let's have a look at a simplified screenshot of Dialogflow and more specifically of the intent screen. This is the intent screen, and the intent you're seeing here is the help intent. So whenever you say something along the lines of, explain please, how does this work, what can I do, help me, Dialogflow will classify it as an help intent, and then it will come up with an answer which is in the bottom part. So the upper part is the input, and the lower part is the output. In this case, the output is really static. It's just hard-coded text. If you want more dynamic output, you need a backend, and we will talk about that in a few minutes. Also, what's in the training phrases, you don't have to say exactly what's there. I think in the demo I said, help me please. And then it also classified my request as an help intent. So say something along the lines, something similar. So then there are parameters and entities. And the easiest way to explain this is by using an analogy. I think most people watching will be programmers, so I will use programming analogies. So whenever you encounter in Dialogflow an entity, in programming we would call this an enumeration or a type. So an example would be days in a week, just a list from Monday till Sunday of possible values. Then whenever you see a parameter in Dialogflow, in programming we would talk about variables. And a variable has a name and a value. So in the example, day is Monday, day would be the name of the variable and Monday would be the value of the variable. So Dialogflow has all kinds of default entities. Think about zip codes, days in a week, months, stuff like that. But you can also create your own entities. And for the game, I needed an entity called direction. And it contains all the cardinal directions. So north, south, east, and west. You will see those applied in a minute. So let's apply all those concepts and bring them together. So again, we're looking at a simplified screenshot from Dialogflow. And now we're looking only at the input part of an intent. And what I did, I typed in move north. Then Dialogflow is smart enough to recognize north as being one of the values of the entity direction. So what it does, let me grab my mouse. It creates a parameter, which we in programming would call a variable. It gives it a name, direction. It gives it a type, add direction. So it can contain north, south, east, and west. And it resolves the value. So it looks like this. It says the value will be north. So let's do exactly the same in a programming language like Java. First, there's the type, add direction. Notice the same color coding. Then there's the name of the variable, direction, and then there's the value, north. So by enabling those three concepts, I only have to create one move handler. The screen we're currently looking at, we only need one move intent. This move intent can handle the north, the south, the east, and the west. If I couldn't apply those concepts, I've had to create 4 move intents, which is cumbersome. So by using entities and parameters, I can keep my stuff generic, and that's something we like as programmers. So that's all about frontend. Let's continue with the backend. So the backend has 3 responsibilities. The first one is execute game logic. So let's apply an example. If I'm in the game and I say go north, then the backend will check if there is a location to the north. If there is no location to the north, it will come up with an error response, and it will say something like you cannot go there. If there is a location to the north, then the game has to update the state. The location of the player has to change. And furthermore, the last responsibility is it has to come up with a proper dynamic reply. So in case of moving to a new location, it will tell you the description of the new location. So I explicitly said dynamic reply. Remember in the screenshot of the help intent, there was like a hard-coded string. Now we have the dynamic replies. So whenever you want dynamic replies, you have to use a backend. The game is written as a serverless Java function on AWS. You don't have to write your backend in Java. You can write it in any language that you like. And furthermore, you don't have to run it on AWS. You can run it on any cloud provider you like. There are only a few constraints. The first constraint is that your backend should expose a REST endpoint. And this REST endpoint has to be reachable from Dialogflow. This REST endpoint also has to consume Dialogflow requests and has to produce Dialogflow responses. Let's have a look at those messages. So first, the Dialogflow request. I'm going to show you a partial JSON. It's not a proper JSON, and I'm only going to show you the most important fields. So it starts with a query text. In this case, it's go west. So the players that go west to the game, and Dialogflow used speech-to-text algorithms to translate it into the string go west. Then there are optionally parameters, and here we have a direction. Its value is capital W, which signifies west, of course. And finally, there's the intent. Dialogflow will capture the intent of the user and will present it to the backend. So this is, in a nutshell, a Dialogflow request. This is all the data that goes from the front end to the backend. Then the backend has to produce a Dialogflow response. So it will read the request, do its magic, which I will explain in a minute, and then has to produce a response. And again, I'm going to show you a partial JSON, but only the most important fields. So first, there's the fulfillment text. This is the text, this is the answer of the game. So whenever you did a go north, it will come up with a description of location. You are standing, blah, blah, blah. But there is another important thing, and that is called the output context. This object is used to keep track of context. Dialogflow enables you to keep track of context. And this is really helpful because if we want to play a game, we also have to keep state. To be able to play the game, we at least need to know where the player is. So the location of the player is an important state parameter. State is something that happened in the past. Context is something that happened in the past. So we can use this context object to store our state in. And that's really helpful because I prefer to write stateless backends because those are far easier to create, to debug, to test, actually easier in everything. So we're going to put the state in the messages, and I will explain it a little bit more in a minute. So state. Actually, we need 3 state parameters to be able to play the game. I explained the first one already, location, and you need to know where the player is. If you want to pick up the handle, you have to be in the location where the handle is. If you want to use the handle on the well, you have to be in the location where the well is. So location is important. Then there is inventory and removed items. In the demo, we picked up the handle. So at that moment, we added the handle to the inventory. So this parameter would have 1 item. Then we went to the well and we used the handle on the well. At that moment, the handle went from the inventory to removed items. So the inventory is the stuff that you're carrying around and can use. And the removed items is the stuff that you used in the past and cannot use anymore. So only those 3 parameters is enough to play the voice adventure. A little bit more about the state and putting the state in the messages. I want to show you graphically how it works because I think that helps. So whenever the first request goes from the front end to the back end, there is no state. Nothing has happened yet. So then the back end gonna put a context object on the response. And as a consequence, Dialogflow, the front end, will put exactly the same object on the next request. Then the backend can modify this context or this state and put it on a response. And again, Dialogflow will put exactly the same object on the next request. So by using this mechanism of putting everything in the messages, state will be contained. There will be state and it will be in the messages. I hope this is clear. Otherwise, hopefully it will become clear during the live coding session. So last slide for the live coding. How are we doing for time? Excellent. Handlers. I told you the game has a lot of intents. We've seen the help intent, we have seen the pickup intent, we have seen the move intent, the use intent, so a lot of intents. Every intent is a handler, and a handler is a class in the backend that will take care of its corresponding intent. So let me give you an example. Let's do the move handler, but actually all the handlers have the same build-up. But the first thing the move handler will do is check validity. So let's assume we want to go north. The first thing the backend does is checking, is there a location to the north? If there isn't a location to the north, error message, you cannot go there. And if there is a location to the north, it has to update the state. So the location parameter you just saw in the JSON will be updated to the new location. And finally, it has to come up with a reply. And in the case of a move command, the reply will be the description of your new location. So those 3 states can be found in every handler. Okay, a live coding part. Like I said before, it's a Lambda on AWS. It's coded in Java. Why is that important? We're going to make some changes in the Java code in IntelliJ in a minute. And once we're done, we're going to upload it to production. And we're going to test it in our simulation environment to see if it works. What we are going to do is we're going to improve an existing handler. So you've seen me play the game, and I think there's something wrong with the game. I think we can improve the game. What I want to improve is the following. Whenever you go to a location, it will give you a description of that location. And this description can be pretty lengthy. And that's annoying, because if you have a lengthy description, you have to wait for about 10 seconds before you can continue playing the game. I think we can improve that. What I want to do, I want to add a feature. Whenever you go the first time to a location, you get a long description. And whenever you go all the other times, you should get a short description. So let me first show you the problem in the game, and then we're going to start coding. So I'm going to start up the game.
Getting the test version of Voice Adventure. Hi, welcome to Voice Adventure. You play this game like a text adventure, but instead of text, you use your voice. You can directly start with issuing commands or ask for more help.
Okay, I'm going to go north, and then it will give you a description of the location, which will be the long description.
You are standing in front of a big castle. There is a door, but it is locked.
Okay, now this is a long description, that's correct, but it's only like 2 sentences, not that long. Let's go south. Of course, that one is much longer.
You are at a crossing. In the north, you see a castle. In the east is a clearing in the woods. In the south is a cave. In the west is a well.
So this is a pretty lengthy description. It takes about 10 seconds to pronounce this description, so you have to wait as a player, which is annoying. So this is what we're going to fix. The next time when we're going to play the game, I hope it will give you a short description, at least the second, the third, and the etc. times. So the first time, long description, all other times, short description. I hope the problem and the solution is clear. We're going to go to IntelliJ. So before we're going to start coding, I'm going to give you a short overview of all the files in the game. Not all the files, but the most important ones. So the most important directory is the source directory, of course. So let's open that one up. Then there's the main folder and the test folder. And before I'm going to continue, I'm going to run all tests because I want to start from a position where everything is right. I don't want to start if there is something is broken and a test fails. So we're going to wait for the test. If you're wondering why it says Groovy over here instead of Java, that's because I prefer my unit test in Spock over JUnit. I'm also doing presentations about that. If you're interested, you can look me up at YouTube. So 38 passing tests. So our starting point is great. Let's go back to the main folder. So it's written in Java, as told before. And then this is the entry point of our application. So whenever you write a Lambda, you have to specify which method will be the entry point for your application. In my case, the entry point is the handle request. And this handle request has 2 important parameters, an input stream and an output stream. Now we're going to walk through the method because this is the main game loop. This is what happens all the time. First of all, the input stream is read. And all the data in there is translated into a request object. So now we can easily access all data from the request. Then we ask for the intent, and we get the corresponding handler. So every intent had a handler. So here's where we get the handler. This handler is then used to call the update state method on it. So this will take care of the request and produce a response. At least it will produce an answer. And so here's the answer. And then we're going to create a reply object, which contains the answer and also the state, as shown before in the diagram with all the arrows. And finally, we write the reply to the output stream. So this is the main game loop. And there's a request coming in, we apply the handler, and then there will be a request. This is how it will work the entire time. So a few more files I would like to show. First of all, there's the item enumeration. So this contains all the items in the game. And then there is the location enumeration. It contains all the locations in the game. There are only 5 locations in the game. So during the demo, you saw a great part of the game. But more importantly, there is a short description and there is a long description. And this is what we're going to use in our new feature. Then there is the message package. And you've seen the request, you've seen the reply. We're going to skip the parameters, but we are interested in the state variable. We're going to do stuff in there in a minute. And finally, there is the handler package, which contains all the handlers I talked about. So back to the feature we want to add. I want to add a feature. Whenever you go for the first time to a location, you get a long description. And whenever you go all the other times you go there, I want to have a short description. Now, to be able to create this, we have to keep track of all the locations where the player has been while playing the game. Keeping track, context, state. We have to do something in the state object. So the state object is on the screen. I'm not gonna show you everything, but over here, you should recognize this. We needed 3 state parameters to be able to play the game. We need a location, we need an inventory, and we needed removed items. Now we're gonna add one. I'm just copy the line. Oh. I call it visited locations. And this will be a set of location, not of item. That's too bad. Location. So what I did is I added the state parameter, but I didn't use the state parameter yet. So what I need to do next is whenever a reply comes in, I have to read the reply and fill the visited locations variable I've just added. And whenever I write a response, I have to put the visited locations in there. So let's start with the first one, the request part. Okay, whenever a request comes in, we have to create a new state. So here is the constructor of state. So we have to fill the visited locations variable. I'm just going to copy a line, just the last one. We want to fill something called visited locations. We will not put items in there. We put locations in there. And finally, we need to know how is it called in the JSON. What is the key in the JSON? So let's call it visited locations. This key doesn't exist. This constant doesn't exist. So IntelliJ, please create it for me. And bam, there it is. So we can give it any name because the frontend will just copy it and the backend will use it. So my name would work, but we're going to give it a proper name. Visited locations. Then we put it next to the other state parameters. So now we have 4 state parameters when playing the game. I go back to the previous file, which is the state class. And those letters were red before, and now they are purple. So everything is compiling again. Let me go back here. So that was the request part. Now I have to do the reply part. So whenever this variable is filled, we have to put it in a reply. So I go to the next method, which handles the reply part. And again, I'm copying this line. So removed items should become visited locations because we want to write this key to the JSON. And the contents of the key will be visited locations. So I did 3 things. First, I've added the state parameter. Then I handled the request part, and then I handled the reply part. So our work to the state class is done. Actually, I've added the capability of keeping track of state. We don't use it yet, but the capability is there. So because we don't use it yet, all tests should still be green. So let me rerun the tests to see if all tests still are green and I didn't break anything. I expect 38 green tests. Love you, demo gods. So before we're going to continue implementing the feature, because of time constraints, I've already written a test for the new feature. So I just have to enable it. I'm looking for the time. Oh yeah, okay, we're doing great. And I have to go to the test, so which is called move handler test. I don't know why, but IntelliJ keeps making this little window littler, more little, I think. So here's the test, the move handler test. So I'm not going to explain it. I'm just going to enable this line because we need it. Otherwise, the test will fail. And here is my new test. The name of the new test is second move short description. Now, it's written in Groovy, in Spock. You don't have to understand it. The most important part is here. We're going to check that the reply will have the short description and not the long description. So I'm going to rerun the test, and I expect the new test to fail. So now I expect 39 tests, and one of them should fail. Hey, 39 tests, 1 failed. Let's double click it. It's exactly the test I just uncommented. So that's awesome. So let's make sure that this test will be green in the next run. So I go back to the move handler. I get rid of this panel. Okay, so this is the move handler. It's a pretty simple class. I'm just going to walk you through it. It only has one method, the update state. We have seen this method already from my explanation from the main game loop. And its only parameter is a request. So the first few lines is about getting data from the request. The only important one currently for us is the current location. So this is where the player currently is. Then there is a default reply, cannot move there, which is specified on top, you cannot move there. So the first thing this method does is trying to move the player to the new location. So assume the player is at go north. Then this move method tries to move the player to the north. If it's not possible, the new location will be equal to the current location. So the move did not take place. If it is possible to move to the north, then the new location will be different from the current location. So, and this mechanism is used in this if. If the new location isn't equal to the current location, so the player has moved, then we're going to do some stuff. So what do? First, we change the state parameter location and we set it to the new location because the player has moved to a new location. Then we have to come up with a reply. And that's what happens here. So the reply will be the long description of the new location. And this is where the problem is. It will always give me the long description. And that just takes so long. So what we're going to do, we're going to do two things to this file. First, there needs to be an if here. Sometimes you want a short description and sometimes you want a long description. But there's another thing we have to do, and that is adding the location to the new state parameter. So we've created a state parameter, which is called visited locations. And now we have to add stuff to it. If we don't keep track of it, the feature will never work. So I'm going to start with the last part because that's the part I always forget when I prepare for this demo. So what we have to do, there's a state. I'm going to add a visited location. And this will be the new location, of course. So IntelliJ says that method doesn't exist. Now, IntelliJ can help me there. So it creates the method for me, and I just have to do a one-liner. So I have this visited locations parameter, and I'm going to add the new location to there. So this simple method, with this simple method, you can add locations to the visited locations set. Let's go back to the move handler. All the red characters are gone, so it compiles again. Neat. And now I have to do the if, my last change. So this one, sometimes I want a long description, sometimes I want a short description. So let me type a little bit. State get visited locations. So let me explain this to you. If the new location is in the set visited locations, we've been somewhere before. So it's not the first time I go there. I want a short description. So reply is new location. Typing is hard, especially when you're doing a demo. So, and in all other cases, I want the long description. So let's first implement the missing method, and then we're going to see if the algorithm is correct. So I'm missing this one. So it proposes to return a collection of objects. I wanted to return a set of location. And this one is even simpler than the one before. I just have to return our new variable, the one we've created. So let's see if that solves the compilation problem. The red color is gone, everything compiles again. So let's revisit the if. Let's see if we've done it correctly. So the if says, if the new location is in the visited locations, then I want a short description. So new location and visited locations, yeah, that's correct. Because new location and visited location means we've been there before. And if we've been there before, we want a short. In all other cases, we want the long. I think it's implemented correctly. Let's ask the tests. I expect 39 green tests. Yes, 39 green tests. Okay, according to the test, we implemented our feature correctly. So time for the next step, bring it to production. So bringing to production is actually uploading the Lambda. And I'm using a plugin for that called the AWS Explorer. Really nifty thing. Let me click a little bit and I'll explain everything it does. So I press update function code. And then I have to wait because it has to load this thing. And once it's loaded, I can press update and explain. So before using this plugin, I did all things by hand. So first I had to go to my browser. I had to go to AWS. I had to log in, do multi-factor authentication. So I had to grab my phone, fill in the number. Then I'm in the AWS console, which is really big and has a lot of features. And I have to find the Lambdas. I have to go to my Lambda. I go back to my local machine. I'm going to do a Maven package. This will give me a jar file. And then I have to upload the jar file by hand. So explaining this took longer than using the plugin, because you see down here, it says code updated for function voice adventure. So long story short, use the plugin. It's uploaded, so time to test it in production. So let's go to the simulation environment again. I'm gonna reload the page. And I'm gonna start the game.
Let's get the test version of Voice Adventure. Hi, welcome to Voice Adventure. You play this game like a text adventure, but instead of text, you use your voice. You can directly start with issuing commands or ask for more help.
Direct start by issuing commands. That sounds exactly as we want to do. So what we're going to do is we're going to go north. And this is the first time we're going to go north. So I expect a long description.
You are standing in front of a big castle. There is a door, but it is locked.
2 sentences, not that long, but it is the long description. Now I'm going to go south, and this one is a really long description.
You are at a crossing. In the north, you see a castle. In the east is a clearing in the woods. In the south is a cave. In the west is a well.
So 5 sentences. It took about 10 seconds to pronounce this. So now we're going to test our feature, because now I'm going to go north, and this will be the second time I go north. So now I expect a short description, so 1 sentence. Let's see what happens.
You see a big castle.
Yes, 1 sentence. So let's go to the south, where the difference will be really beneficial.
You see a crossing.
Only 1 sentence instead of 5. So big win. I'm really happy. The live coding part went successfully. Nothing broke. Really happy. So let's go back to the presentation and wrap things up. So the conclusion already. I've shown you in the last 40 minutes, it's pretty simple to build your own app. If you want to, you just use a front end, in which you should use Dialogflow. Almost everybody uses Dialogflow, and it's just a no-brainer. Use Dialogflow. If you want to write a really simple app with static answers, Dialogflow is enough. But if you want to do something a little bit more complex or a lot more complex, then you have to use a backend. Remember, you don't have to write your backend in Java. Any language is fine. You don't have to use AWS. Any cloud provider is fine. So I gave you a simple example. I showed you my little game, the voice adventure, but I think it contains concepts that everybody can use. The first concept is every intent should have a handler. So this mechanism works really well, and I think it will work really well for most applications. And finally, put your state in the messages. Use the context outputs object. So you have a stateless backend, and so everything will become easier. So questions. Now I'm looking at my co-companion, presenter, Danielle. Are there any questions?
Yeah, we have one question, but let me thank you for the great presentation. I think we are all expecting a full game now. We want to go north and south, and grab all the items and find all the items. So I have a question here from Thierry Lafayette, and he's asking if you have used module-based Java 11 code to create your jar file, or the good old monolithic jar file.
Yeah, good question. When I started building this game, which was like 2 years ago, I don't think Java 11 was there, so I used Java 8. But recently I've upgraded to Java 11, but I didn't use a module system. It's just one big jar file. And to be honest, it is a small game. I think you saw about 20 files. There could be a benefit of using the module system, but I think it will be really small.
So on the full game, we can expect the module system.
I feel some kind of obligation here. But
no pressure, man.
2021, the full game.
Okay. So I don't see any other questions either on Slack or YouTube.
That's fine. I have 2 slides left, so let me just finish.
Go. And then, yeah, of course.
We're done? Okay, cool. First of all, I have 2 links. The first one is a link to the source. So it's on GitHub. You can just see the source if you want to play with it or modify it. It's yours. And the second one is a link to the game. So there you can play the game. Don't play too fast because the game is not that big. Finally, I would like to thank you. I would like to thank everybody who's listening, watching, for being here. I hope you learned a new thing or two. If you have comments, remarks, questions, my Twitter handle is in the bottom right corner of every slide. So please contact me there. Thanks again, and I hope to see you next year. Bye-bye.
Thanks, Bouke. Hope to see you back in Generation in the future, preferably in Coimbra on site instead of online. Let's see how we handle this pandemic. Thanks a lot. And if you need anything from Bouke, try to reach him through Twitter, as I said, or just drop questions in the Almadina chat, and we'll try to reach him. Thanks a lot once again, Bouke.
Thank you as well. Bye-bye.
See you later, guys.